This meeting is being recorded. This meeting is being recorded. Good morning, all. Hope everyone is having a good Wednesday morning so far. And so today we're going to jump into Chapter 1. Chapter 1, entitled Portable Electronics, the periodic table in the palm of your hand. And so we're going to focus in this chapter on matter. And we're also going to focus on learning some initial things about the periodic table, including the elements that reside on our periodic table. So before we dive into Chapter 1, did everyone successfully register for Mcgraw-Hill Connect? If you haven't successfully registered, or if you experienced any issues or problems registering, and if there's going to be a delay in you getting registered before the week is out, please let me know. I highly suggest that you get registered before the week is out, and that by Friday you've gone through the material in the Getting Started and Introduction modules on our eLearn site under the Course Content tab, and then that you're ready to begin Chapter 1 homework, as well as going back over and studying the notes in Chapter 1 that we go through today. So this weekend, you should be well into your studying of Chapter 1 and beginning the Chapter 1 homework. Now, with the Chapter 1 homework in Connect, you can do a certain portion of the homework today and then come back tomorrow and pick up where you left off and continue with the chapter. So if you want to do one section of the chapter per day, you can do that. And you'll be able to pick up where you left off with the percentage that you've already completed and continue on. So you don't have to do the homework all in one sitting. You can split it up however you desire. As long as you've got it completed 100% by the due date, then you are fine. Any questions about Connect before we begin Chapter 1? Okay, so if there are no questions, I don't see any hands raised. So if there aren't any questions about Connect or any questions about anything on our eLearn site, we will begin Chapter 1. So the first section of the chapter focuses on how touchscreens work. Well, the way touchscreens work is that they respond only to certain stimuli. So we know from everyday use of our cell phone that your cell phone's touchscreen responds to you. It responds to your finger when you place your finger on that touchscreen. So your finger is a type of stimulus. And so your touchscreen, we know for sure, responds to us, the human being, our finger. And so if you have your cell phone close by, which I'm sure most of us do, grab your cell phone really quick. And we're going to do a little activity. We're going to make a stimuli and response table. So I know that my finger responds to my cell phone. And so when I use my finger, my cell phone responds to my finger. And so I get a response. When I use my finger as the stimulus on my touch screen. So therefore, my table, my finger is definitely a type of stimulus that my touch screen responds to. And so I can try some other types of stimuli. So for instance, if I take this plastic spoon and I touch my screen with the plastic spoon, well, my phone is not responding to the plastic spoon. It's not causing any changes to my screen. Those different apps are still there. So my phone doesn't respond to the plastic spoon. If I try another type of stimuli, let's say this penny that I have in my hand, my phone responds to the penny. And so my screen changed. And so I'm going to select this email using my penny as the stimulus instead of my finger. So using the penny to touch my screen, my phone responds to that stimulus. And then I have a pair of scissors. So I'm going to touch the tip of the scissors to my screen. And I notice that my screen doesn't respond when I touch it head on, but when I touch the screen to the flat part, with the scissors flattened out, my screen responds. So the answer to whether or not my screen responds to the scissors, well, yes, if I touch the screen with the widened surface area portion of the scissors. But if I touch the screen with the flattened, with the pointed tip of the scissors, my screen does not respond. So think about that. Why does it not respond to the single tip of the scissors, but it does respond when I touch with the flattened portion of the scissors, causing a larger surface area of the scissors to be in contact with my screen. So I tried 3 other stimuli. And I know that, of course, my finger responded, my screen responded to my finger. But the screen did not respond to the plastic spoon. It did respond to the scissors when I exposed a larger surface area of the scissors to the screen. And my screen did respond to the penny. So if you have your cell phone, what I want you to do is choose 1 or 2 different stimuli, maybe something different than what you saw me just choose, and see if your touchscreen of your cell phone responds to those stimuli. And so what I want you to do is go to your particular group and go into your particular group room, and then try to find at least 2 different stimuli, like an ink pen or a pencil Or another type of coin, I use the penny. So if you want to use a quarter or a dime or a nickel, I use the plastic spoon. You can use a metal spoon. So just go and get 2 different stimuli. So if each person in your group has two types of stimuli, you'll be able to compile a good list of stimuli together and put yes or no in your own table. Draw your own table like I've drawn, and denote whether or not that type of stimuli invoked a response by your cell phone screen. So there were 2 different meeting rooms open. Whitney, I see your message, Whitney and Tessa. I did open the room early to test to see if I can connect my iPad, which is what you're seeing on the screen now is from my iPad. So I wanted to test to make sure I could share my iPad with you guys on my laptop. So that's probably why I'm going to check that. I'm going to close the other meeting room. I was thinking that I was in the Wednesday morning. I did click on the Wednesday morning join. I may have clicked on the Monday morning join by accident. And so both the Monday morning and Wednesday morning may be open. So I'll check that and I'll close the Monday if that's the case. Thank you for alerting me of that. Okay, I'll go jump into that room and see if there's still people there and to direct them to join us. So for those that are here in this meeting room, go to your group breakout rooms and you should be able to just click on Teams. And then those different group rooms should show up, and go ahead and click on your group. And I will be right back. And I'm going to go find that other meeting room that's open and see if there's still people in there and direct them to this one. So that once you're done discussing your list within your groups, come back to the general room. So now that you've had a chance to go to your breakout rooms, discuss your list of stimuli and responses, what did your yes response type stimuli, what did they have in common? And so one way that you can respond to questions is you can just type in the chat box. Or if you hover your mouse over your screen, a little bar should come up with the video camera, microphone. Unmute yourself, turn your microphone on, and you can speak. Or you can use the hand, raise your hand, and I'll see your hand being raised, and I'll acknowledge you, and then you can proceed to answer the question that way. So those are the 3 different ways that you can answer a question in class. Use the hand wave, or just simply type in the chat box, or you can just unmute yourself and speak freely. I see Tessa's response in the chat box. The ones that did respond to your screen, they all conduct electricity. And so, Caitlin, your group, nothing that you tried worked but your finger. Okay. All right. So, if you look at my list that I have here, those things that gave a yes response were just like Tessa said, the things that can conduct an electrical current. So your human body is a conductor of electricity. So that's why your touchscreen responds to your finger. The scissors and the penny, those are all metals, and metals are conductors of electricity. So that's why the plastic spoon didn't work, because it's not a conductor of electricity. Plastics are not conductors. Plastics are types of insulators. Plastics, ceramics, those are all good insulators and not good conductors. And with my scissors, when I touched the tip of the scissors to my screen, I didn't get much of a response. But when I touched more of the flattened surface area of the scissors to the screen, I got a response. Gavin, did you try one end of a battery? Did it work? Okay, the battery worked. Yes, because that end of the battery, those are metal components that make up the battery. Very good. So what about the flattened portion of the scissors working, but not the very tiny tip of my scissors? Why did I observe that? Why didn't the little tiny tip of the scissors touch to the screen? Why didn't the screen respond to that? Any ideas? Very good, Ewan. More surface area is needed. Because we use our fingers. That's the main thing that we use to operate our touch screens. Some people may use a stylus. If you're a particular brand of cell phone, like the new Samsung Galaxy Note type Android devices, they have their own little stylus that comes with them. So your finger, or if your phone comes with a stylus, that's what you use to operate the touchscreen. So even if you have a metal like the tip of my scissors, the tip of my scissors diameter is not as big as the diameter of my fingertip. So even if you have a metal touching your touchscreen, we know a metal is a good conductor of electricity, but if it's very narrow, like the tip of the scissors, your touchscreen is not going to respond to it. What you touch to, it has to have a diameter that's similar to that of your finger. Very good. Very good test. It senses larger items that have a similar width or diameter of your finger. And so we've answered that question. Only those that conduct electricity and have surface area similar to your finger. Okay. So has anyone used those gloves that have a special material so that you can keep your gloves on if you're out in the cold and still use your cell phone because of that special material in the tip of the fingers of those gloves that are conductive of electricity? That's why you can use those special types of gloves and keep them on while using your cell phone, which is very important if you're in a very cold environment and you're outside needing to use your cell phone. And so your touch screen is made up of many different types of materials. You have a protective anti-reflective coating and protective covers. And then you have these different layers, the bonding layer, driving lines, and sensing lines. And they all sit on a glass substrate. Now, these protective covers and the glass substrates, those are all insulators. Those aren't conductors of electricity. What the conductors of electricity are your driving lines and your sensing lines. Those components of the touchscreen is where your metals are. And so therefore, when you touch your finger, which is electrically conductive to that screen, the driving lines and the sensing lines are responsible for, therefore, invoking a response based on being touched by your finger. So now that we've kind of gone over how touch screens work, let's go deeper into the study of chemistry and defining some things about chemistry. And so chemistry is basically the study of matter and the changes that matter undergoes. And these changes can be physical changes or they can be chemical changes. And so with chemistry being the study of matter, matter is anything that has mass and takes up space. And matter can exist in 4 different states: solid, liquid, gas, and the 4th state, plasma. And so the main 3 states of matter that we'll be responsible for this class are just solid, liquids, and gases. And solids, liquids, and gases differ from each other on a molecular level. And so here is a diagram of a sample of a solid. Notice the particles that make up the solid are in very close contact with each other. They are touching each other. And because they're touching each other, notice there's a pattern to how the particles are arranged. And so therefore, particles of a solid are arranged in a very structured, ordered manner. And because they are arranged in such structured and ordered manner and they're touching each other, they are relatively stationary. So these particles or these atoms that make up this solid, they're very stationary. They're not very mobile. So they have no freedom of movement. However, they do vibrate. Solids are not very compressible, meaning that you can't compress their structure very easily because they have a definite shape and they have a definite volume that they will maintain. Now, liquids, on the other hand, if we take a look at a sample of a liquid, we notice that the particles making up the sample of liquid aren't in a structured and ordered pattern like in a solid. They are less structured. And so they're not touching each other as closely as the particles of a solid do. So they have some small spacings between them. And therefore, they have intermediate mobility. So they do have some freedom of movement. And just like solids, liquids are only slightly compressible. And because their particles that make up a liquid are spaced out a little bit from each other, liquids have no definite shape. But they do have a definite volume. And then finally, gases. You notice that the gas particles are spread out far apart from each other. And they have complete freedom of movement. So they have kinetic energy because they have freedom of movement. And so they're very mobile. They have kinetic energy. So they move, they have a high speed or high velocity. Gases are highly compressible because their particles are spread out so far apart from each other. They're very highly compressible. And gases do not have a shape, nor do they have a volume. So gases take on both the shape of the container that they're in, and they will fill the volume of a container. Like if you've ever bought a propane tank of gas for your gas grill, you fill that propane tank. That propane gas is going to fill that entire volume of that tank. And it's going, the particles are going to take on the shape of that tank. Liquids, on the other hand, will also take on the shape of the container that the liquid's in, but the liquid will maintain its own volume. And so we looked at the three main states of matter that we're going to be responsible for this class. These states of matter can be interconverted. And when they are interconverted, they're going through a physical change. And therefore, interconverting between solid, liquid, and gas phases being a physical change that takes place without changing the chemical composition of the substance. So therefore, changing phases does not involve any chemical changes, but does involve physical changes. So therefore, you can change a solid into a liquid and then go on and change that liquid into a gas. And you do so by adding heat. The solid to liquid transition is called, of course, melting. Melting is also called fusion. And then the liquid to gas conversion is evaporation. And then you can go in the opposite direction by removing heat. So converting a gas to a liquid by removing heat is a process called condensation. And then converting a liquid to a solid by removing heat, of course, is freezing. Now, two other physical changes take place that involve phase changes. And they involve a solid going directly to a gas, or vice versa, a gas being converted directly into a solid. So the solid to gas conversion is called sublimation, and the gas to solid conversion is called deposition. And so we've talked about the three major states of matter. And so we said that matter is anything that has mass and occupies space. And so the very smallest entity of matter that can't be divided or broken down into any simpler means is called the atom. So all matter is composed of atoms. And an element like those that are on the periodic table, the elements that are on the periodic table are composed of many atoms that are of the same type. So for instance, the element carbon, that element consists of many different atoms of carbon. That's what makes a sample of carbon carbon. It consists of only carbon atoms. So therefore, the type of atom is specific to a specific element. And so if we take a look at the following table, we have the four states of matter listed here: liquids, gases, solids, and also plasmas. Those are your four types of matter. Now, when we want to classify matter, that's different than just talking about what state the matter is in. So when you're talking about what state it's in, what is the physical state? Is it a solid? Is it a liquid? Is it a gas? Or is it in the plasma state? But then we can further classify matter as far as the type of matter it is, based on what the particular type of matter consists of. And so matter can either be a pure substance, or matter can be a mixture. And so a pure substance cannot be separated. So the components of a pure substance cannot be separated by physical means. However, the components of a mixture, they can be separated by physical means. So a pure substance, the components that make up the pure substance cannot be separated by physical means or physical methods. but components that make up a mixture can be separated by physical methods. So there are two types of pure substances that exist: elements and compounds. Now, elements are composed, like we stated earlier, of many atoms of the same type. Compounds, on the other hand, are composed of two or more different types of atoms, whereas elements are composed of many atoms of the same type. So an example of an element is any of the elements that are on the periodic table. For example, the symbol Na is for the element sodium. The symbol C, capital C with a lowercase l, is the symbol for the element chlorine. So these are elements. A sample of sodium is made up of sodium atoms. A sample of chlorine is made up of chlorine atoms. Now, if we put these two elements together and bond them together, we make NaCl, which is sodium chloride, which we also know as common table salt that we have in our kitchen. So sodium chloride, or what we commonly call table salt, is a compound. It is composed of two different types of atoms, a sodium atom and a chlorine atom. Water, H2O, can also be considered a compound because it's made up of two types of atoms. It has hydrogen atoms, has two hydrogen atoms in its formula, and one oxygen atom. So if I take some salt, sodium chloride, and put that sodium chloride in my sample of water, the water is in the liquid state, hence my little lowercase letter L there. The salt, sodium chloride, is a solid, hence the letter S next to it. And then, of course, like we've done many times, if I stir this mixture with a spoon, and note that, yes, this is a mixture. At this point, I have two different components, water and salt. And then when I stir, the salt dissolves. And now I have what's called a salt solution, which is a homogeneous mixture. Before I stir it, I have what's called a heterogeneous mixture. So what's the difference between my heterogeneous mixture here and after I stir, the solution or the homogeneous mixture that results from the stirring? Any ideas on the difference between the heterogeneous mixture versus the homogeneous mixture? What's the difference between the two? Right, Tessa says the heterogeneous one still contains some of the visible solid. So what Tessa is saying is that the heterogeneous mixture is not uniform throughout. I've got solids sitting on the bottom of the cup, and I have no solid salt residing at the top layer of the water towards the middle of the cup. So therefore, with the heterogeneous mixture of salt and water, the mixture isn't uniform throughout, meaning that I don't have the same amount of salt at the top of the layer of the liquid that I have at the bottom of the layer, the bottom of the liquid at the bottom of the cup. But when I stir, I dissolve and mix that salt evenly into the volume of the water. And now my salt is distributed uniformly throughout my sample of water. And that's what makes it a homogeneous mixture, because the salt is no longer visible, because the salt is now distributed uniformly or evenly throughout my sample of water. So now I have what's called an aqueous solution of salt. And that's what that symbol AQ here stands for. Aqueous. Because now my salt is completely dissolved in the water. So I still have a mixture, but now the mixture is homogeneous. Whereas before I stirred, it was heterogeneous. And so we've gone over most of the items in our flow chart here. We've looked at two different types of pure substances, elements versus compounds. And then we've looked at mixtures, heterogeneous versus homogeneous. Now we said that what makes the mixture different from the pure substances is that the mixtures can be separated by physical methods. So take a look at our homogeneous salt solution that we just made. Can I separate out the two components of this homogeneous mixture with a physical method? And if so, what physical method should I use? Or do I need to use more than one type of physical method? So my components are salt and water. What physical methods could I use to separate the salt from the water? Any ideas?
Evaporate the water.
Very good. Filtering. Filtering is a good way to do it. I would have to use some filter paper that has really, really tiny pores so that the pores are big enough to let the water pass through, but are not big enough to let the salt pass through, and the salt gets trapped. Evaporate the water, Nicholas. Very good. We can put the salt water in a pan, put it on the stove, boil it. The water will evaporate. The salt will be left in the pan. Very good. So those are two physical methods that we can use to separate the components of this mixture. Have I done a chemical change when I put that salt water on the stove and boil it? That's not a chemical change. That's just a physical change. I still have salt and water. The water is just now evaporated, and it's a part of the humidity of my room now. But it's still there. I haven't gotten rid of it. I haven't destroyed the water. I just converted it from a liquid to a gas or a vapor. And then the salt is still in the pan, and it's still sodium chloride salt. So I didn't do any type of chemical change. I didn't make any new substance. All I did was change the physical state of the water from liquid to gas. And then I changed the salt from being dissolved in the water in aqueous solution, and I converted it back to a solid by boiling away the water. So now the salt doesn't have anything to be dissolved in because the water has gone away. So therefore, those were my physical methods that I used to separate my mixture. Now, elements and compounds. Elements are made up of atoms of the same type. Compounds are made up of two or more different types of atoms. Can I use physical methods? For instance, my sodium chloride, NaCl. If I want to separate this sodium, Na, from the chlorine atom, Cl, can I use a physical method to separate those two atoms from each other? Can I use evaporating or filtering to separate that sodium atom from that chlorine atom? Any ideas? Yes or no? Can I use physical methods? Very good, Michael. No. No. We would have to use chemical methods. You are correct. So you cannot use physical methods like boiling or filtering to separate out the different atoms that make up a compound, or for that fact, to separate the elements, the atoms that make up the element sodium or the element iron. You can't use any type of physical methods. You have to use chemical methods. And therefore, you need to have a chemical reaction between that substance and another substance so that you can break the bonds that are holding that sodium and that chlorine together and causing those atoms to rearrange and combine with new atoms from another substance, and therefore you make a totally new substance. So that's the difference between a chemical method or a chemical change and a physical change. With a chemical change, you always make something new. You make a new substance. You don't have the sodium chloride or whatever other starting material that you had in the beginning. If you mix it with something else, you perform a chemical reaction, which is a chemical change, you're going to end up with new products. So that's the difference between a physical method and a chemical method. With the physical method, you're not making a new substance, you're just changing the state of the substance or substances. With chemical methods, you're actually changing the chemical identity of your starting substances by making new substances. So now that we finished section 1.2, I'm going to let you go into your different breakout group rooms again. And we have 2 questions here in section 1.2 that we want to answer. Go to your different group rooms, answer these questions, discuss these questions with each other, come up with your answers, and then I would say give yourself about 7 minutes to do those 2 questions. And then by 11:57, 11:58, return to the general room. And I'll pop into your different rooms and see if your group has any questions for me. And while you're in your room, your group room, if you come up with a question that you want to ask me or the class in general, put your group room on hold by pressing the hang up button, and that'll put you on hold. And then you can jump back into the general room, go to the chat, and type in your question. And that way I know that your group has a question and I can pop into your room. Okay? So go ahead and go into your groups, come back in about 6 or 7 minutes, and we will discuss these 2 questions. Okay, I think everyone's back from their breakout rooms. So let's just quickly go over the answers to questions 1 and 2. So for panel A, did you say that this represented an element, a compound, or a mixture?
It's an element.
Very good. Element, does everyone agree? So we see 2 different colored circles. These 2 different colored circles represent 2 different types of atoms. So if I've got 2 different types of atoms that are connected together, is that going to represent an element, a compound, or a mixture? And I noticed that they're identical. I've got a small brown and a larger beige colored. And then the other one is still that dark brown colored circle and then a larger beige colored circle. So these are the same types of entities, right? Does everyone agree with that? That they're identical? But each one of these entities is made up of 2 different types of atoms. So would A be a compound or an element? That's going to classify more so as a compound because it's made up of 2 different types of elements. So this could be NaCl. That could be sodium. And then the tan colored one could be the chlorine. So it could be a compound. Very good. What about B? Element, compound, or mixture?
Is it a mixture?
Very good. Explain to us why it's a mixture.
Well, because they can be separated. They're not like mixed together. They can be separated.
And there are 2 different types of elements, right? And like you said, they are separated from each other. They're not chemically bonded together like these 2 guys are, right? See, those are chemically bonded together. Because they're touching. And that's what makes them a compound, these 2 guys here. Because those 2 different types of atoms are touching. Here we've got 2 different types of atoms, but they're not touching. But they are in the same container. This is our container. So that would make them a mixture. 2 different types of elements in the same container that are not chemically bonded together. So that would make this a mixture. It's a mixture, if we want to be specific, a mixture of 2 different types of elements. What about C? Element, compound, or mixture? Very good, it's a mixture. We've got 2 different types of elements and also a compound that looks just like the guys in part A. And finally, what about D? Very good. 1 type of atom, so therefore an element. Any questions about number 1? What about number 2? You got A through F, classify them as element, compound, or mixture. Aluminum foil, That would be an element. Thank you very much, Caitlin and Jaden. Charlie, what about baking soda? Baking soda is a compound. I agree. Baking soda is also called sodium bicarbonate. It has the formula NaHCO3. So it's made up of a sodium atom, Na, hydrogen atom, H, one carbon atom, and 3 oxygen atoms. So it's made up of 4 different types of atoms. That makes it a compound. What about milk? Milk would be a mixture. Very good. Milk is composed of lots of different things. You've got protein that is in milk. You've got the sugar lactose that is a part of milk, unless you have the special type of milk that doesn't have any lactose, and they do different chemical processing methods to remove the lactose. And then milk also contains fat. So there are lots of different components in milk, and that makes it a mixture. And Jaden says it's homogeneous. It's a homogeneous mixture, yes. The milk that we buy in the grocery store is a homogeneous mixture. What about when it comes out of the cow? Is it homogeneous or is it heterogeneous? Right, Tessa. When it comes out of the cow, it is heterogeneous. They have to put it through a machine called a homogenizer to make it into a homogeneous mixture. So when it comes out of the cow, it's heterogeneous, but then they put it through the homogenizer to blend all those components together so that it's a uniform mixture. What about the air that we breathe? Very good. It's a mixture. It's composed of oxygen, nitrogen, especially down south, we have more of it than other people. Water vapor, carbon dioxide, and lots of other different components. So air is definitely a mixture. What about copper wire? Very good. And finally, sugar. It's a compound. Very good. The formal name for table sugar that we have in our kitchen is sucrose, and it is a compound. So before we go, we'll introduce the next section that we'll start on Monday. So now that we've got an idea of what makes an element different than a compound, an element is only made up of one type of atom, whereas a compound, like baking soda, is made up of 2 or more different types of atoms. And so the next section, compounding the complexity from elements to compounds, we're going to take a closer look at the periodic table, take a closer look at compounds. And you notice that I mentioned several compounds today, like sodium chloride, NaCl. I mentioned sucrose, sugar, table sugar, who has a formula C12H11O12. And so all of these are chemical formulas. For these compounds. And the chemical formula tells you what type of atom is, what types of atoms is in the compound, and how many of those types of atoms are in the compound. So sodium chloride, our normal table salt, has only 1 sodium atom and 1 chlorine atom. Well, you notice the sucrose, the table sugar, has these subscript numbers that's telling us that we have 12 carbons, 11 hydrogens, and 12 oxygens. Well, if you don't see a subscript number, then it's understood to be 1. So table salt is composed only of 1 sodium atom and 1 chlorine atom, whereas sucrose or table sugar has 12 carbon atoms, 11 hydrogen atoms, and 12 oxygen atoms. So these are what chemical formulas are. They tell you that particular information about a compound, what types of atoms make up this compound, and how many of each type of atom is in the formula for that compound. So taking a look at this first picture, we have 3 different types of matter. The first sample here in panel A is pure iron. With iron has the formula Fe as its symbol on the periodic table. It's number 26 on the periodic table. And we see that iron has the ability to attract a magnet. So this picture is comparing the magnetic properties of these 3 different substances. So pure iron is a metal, and therefore it has magnetic abilities. It will attract a magnet. The next substance in panel B is rust, which has the formula Fe2O3, meaning there are 2 iron atoms and 3 oxygen atoms. But we see that the rust is not attracted to the magnet like the pure iron is. And then finally, we have this mineral that's found in the earth crust called magnetite. Magnetite has the formula Fe3O4, 3 iron atoms and 4 oxygen atoms. And the magnetite mineral has the ability to act just like a magnet. It's magnet-like because it can attract metals like this iron wire. So these are little pieces of iron wire, and the magnetite mineral acts just like a magnet, and it attracts those pieces of iron wire. So therefore, you see that even though all of these, the pure iron is just pure iron, then the rust has iron in it, which is not attracted to a magnet like the pure iron. And then magnetite itself acts like a metal and it can attract other metals in addition to iron wire to it. So therefore, even though rust has iron in its formula, it doesn't have the same property as pure iron metal or magnetite for that matter. And so we're going to stop right there for today, and we'll pick up here in the notes where we left off in section 1.3 on Monday. And I will have the last part of the chapter 1 notes up before the week is out for sure, so that you can start looking at those. And not only do you need to have this downloaded copy of part 1 of the notes in class on Monday, but we'll also, in addition to finishing part 1, we'll start on part 2 of the notes on Monday as well. And I'll get those notes up for you before the week is out, so you can go ahead and look at those ahead of Monday's class. So if anyone wants to hang out in our meeting room for a few minutes after class, I'll hang out. And if you have any questions, please feel free to stay and ask your questions. Otherwise, have a good lab meeting this week. We are meeting in lab. Most of you will meet for lab either tomorrow or others will meet on Friday morning. We're doing the Classifying Matter Lab. Go to our lab's website, eLearn website, and go to the course content tab. After you've read the news items on the home page, go to the course content tab, read the Getting Started module materials, and then go to this week, the week of August 24th, download the procedure and data report sheets for the classifying matter lab. Have those downloaded and or printed before your lab meeting. And what you'll be doing is you'll be breaking out into different group rooms, just like we've been doing in lecture. And you'll meet with your group. You'll watch some videos as well as discuss all the different components of the lab within your group. You'll fill out your data report sheets. And then each of you individually are going to turn in your own data report sheet to the Dropbox. So once you go to the course content tab for our labs eLearn site, go for this week's lab under the week of 8/24/20, download those procedures and data sheets. You'll also see the Dropbox link there for when you're done with your lab. At the end of your lab period, you will upload your lab report form to that Dropbox. Now, how can you upload your lab report form? If you have a printed copy, and if you don't have the availability of a scanner to scan your report sheets and save them as a PDF file, another method you can use is to take a picture of each of your sheets, save those picture files, and then copy and paste those picture files into a Word document, and then save that Word document as a .doc file, or you can even save it as a .pdf file. I prefer, as a lab instructor, if you don't have me as your lab instructor, one of your other lab instructors may prefer something different. But what I would prefer is that you only upload one single file to the Dropbox. So if you need to take pictures of your various pages, take pictures of those pages, share those pages with yourself, like to your email address or whatever, and then download those by copy and paste each picture into a single Word document, and then save that document and upload that single Word document or that single PDF file document into the Dropbox. Okay, so have a good rest of your day. If you have me for lab, I'll see you in lab either tomorrow or Friday morning. If not, I will look forward to chatting with you again on Monday morning. Absolutely, Whitney. So we have a different eLearn site for lab that's different from our lecture eLearn site. So when you log into eLearn, if you click on the little 9 square waffle, all of the courses that you're enrolled in this semester should appear. And one of them should be CHEM 1010. It'll say -42, 43, 51. There are 3, and then a PSL section as well. There are 4 sections of CHEM 1010 lab, and all 4 sections use the same eLearn site. So you may be in section 42 if you take it at 11 a.m. on tomorrow with me, or you may take Miss Jane. Her lab is at 2 o'clock on Thursdays. And then there's a evening lab with Ms. Johnson at 5:30 Central Time on Thursday evening. Or the 4th section is with me at 9 a.m. on Friday. So no matter which section you're in, you're using the same eLearn Lab site. Once you're on that site, read through the news items that are on the home page, and then click on the course content tab. And then in the table of contents, you've got a getting started, an introduction module. Read through those documents there. And then you'll see the date, week of 8/24/2020. Click on that module, and there you'll find the classifying matter procedure as well as data report form. Download both of those documents and have those either downloaded on your device before lab, or either you can print them out and have them ready for you before your lab meeting. Hi, Hannah. Go back to part C on number 1. Is that what you're referring to? Okay. And so part C what we have here is our light brown circle. We also have a dark brown circle. And then we have a light brown circle and a dark brown circle that are connected together. Okay, so this is, we can call this one element number 1. And then this would be then element number 2. But also we have a compound because we have this type of element, number 1, chemically bonded with and touching element number 2. So this is a compound. So within our container, we have 2 different elements and 1 compound. That makes this a mixture. It is a mixture of 2 different types of elements and a compound. Does that make sense now, Hannah? Any other questions? Whitney, did I answer your question okay? And also, Whitney, I haven't put part 2 of the notes up yet. I will do so before the week is out. Okay, and you'll find part 2 of chapter 1 notes, the same location where you found part 1. It'll be in that same area within the chapter 1 module. So all your lab stuff you'll need to find on the lab eLearn site. Then all the lecture notes and practice work, I'll put those in the lecture eLearn site under the modules for each chapter. Any other questions? Well, if there aren't any more questions, I'm going to go ahead and leave the room. If you have come up with any other questions, just send me an email and I will respond to your email within 24 hours during the week and within 24 to 48 hours on the weekend.